Alright, so this is how we calculate the pH of a solution. Right, so just to get around to this, we need to lay some groundwork, and we need to talk about the pH scale. The pH scale goes from, generally we say it goes from 0 to 14, where 0 is acidic, 14 is basic, and of course right in the middle here is 7, which is neutral. Alright, now, where do we get this value of 7 for neutral from? If you will recall back, when we talk about water, water undergoes this process called autoionization, right? Autoionization, where water molecule breaks apart and gives us H3O plus and OH minus. Now, this happens to a very, very small degree. How small? So, at 25 degrees Celsius, we will find that at equilibrium, the concentration of H3O plus, first, so the brackets mean concentration. Also remember, too, that for our purposes, we're going to treat H3O plus and H plus interchangeably, as at least as it goes to concentration. Concentration of H3O plus obviously is going to be equal to the concentration of OH minus, because for every water that breaks apart, we get one H3O plus, we get one OH minus, and at 25 degrees Celsius, if we were to measure that, we would find that that has a concentration of 1.0 times 10 to the minus 7 moles per liter. Right. Now, to calculate pH, here's the formula that we use. Okay? We take the negative log of our H plus concentration, or we could say negative log H3O plus concentration. Okay? Now, if we were to do that, we take the negative log of 1.0 times 10 to the minus 7, we find that that's equal to 7. All right? Now, all you are going to be responsible for in this class, now there are ways that we could do all of these, but all that we're going to care about is calculating, at least until we get to buffer chemistry, all we're going to care about is calculating the pH of a strong acid. All right. Now, when we have a strong acid, so let's say that we have a 0.05 molar solution of HNO3. Okay. 0.05 molar solution of HNO3. That means that our H plus concentration, which again we can use interchangeably with our H3O plus concentration, and that is going to be equal to 0.05 molar. All right. So, we take the negative log of 0.05 molar, and we get a pH of 1.30, right? That's all there is to it. Now, let's say hypothetically we wanted to calculate, we have an OH minus concentration, okay? So let's say that we have 0.02 molar NaOH. Okay, NaOH is a strong base. That means that our concentration of OH minus is going to be 0.02 molar. Right. Well, to calculate pH, we need an H plus concentration. So we actually can relate OH minus and H plus concentration back together through this relationship. Okay? So, if we take for pure water, if we take our H plus concentration times our OH minus concentration, again, at 25 degrees Celsius, this value is different. This value will actually be larger at higher temperatures, smaller at lower temperatures. But we multiply these two together, we get a value of 1.0 times 10 to the minus 14, right? By the way, we call that value kW. That's the auto dissociation constant of water. Okay. Now, this relationship is always going to be true for any solution at this temperature. So, if we know an OH minus concentration, we can say our H plus concentration is going to be equal to 1.0 times 10 to the minus 14 divided by our OH minus concentration. Okay? So, going back to this, we know that this is 0.02. Our H plus concentration is going to be equal to 1.0 times 10 to the minus 14 divided by 0.02, which is 5 times 10 to the minus 13. Now, if we were to take the negative log of that, we get that our pH is equal to 12.30. Okay, so that's how we can do this for a strong acid. I'm sorry, for a strong base. Now, we also talk about weak acids and bases. We're going to do some calculations when we get into buffer chemistry with weak acids and bases. I am not going to ask you to calculate the pH of a weak acid solution in water, of a pure weak acid solution in water. Why not? That gets into, the math is a little bit more complicated. Actually, it just depends on the specific circumstances. It could be a little bit more complicated. It could be a lot more complicated to the point where we actually need to start using the quadratic formula to figure it out. We do that in Chem 142, and actually most of the time we try to even avoid the situations where we need the quadratic formula. But this covers how we calculate pH for strong acids and for strong bases.